Hey folks, how's it going? This is Mr. Murray coming to you with a Do Now for Course 1 Honors for Thursday, April 30th, 2020. Welcome to the last day of April. And if you think about it, one might even argue we're now a third of the way through 2020. Isn't that crazy? Time's really flying by, as it always does. All right, so welcome to what I might call Throwback Thursday here. And I call it Throwback Thursday because we're going to do a little bit more emphasizing of older content that we've already done during the closure, because this stuff is so important and I want to keep us fresh on it. So what we need to do, solve these three equations. E squared minus 15e plus 54 is 0. 4m squared minus 28 is 80. Negative 49h squared plus 42h plus 6 is 15. Okay, so that's the throwback because there's a little bit more of that than usual. And then write the rule, explicit and recursive. 3, 4.5, 6.75, 10.125. So that's 3, 4.5, 6 3/4, 10 1/8. And then 2/3, negative 4/9, 8/27, negative 16 81st. Okay, so go ahead, pause the video, solve the three equations, write the rules for the two sequences, and then when you're ready, unpause, and you can see what I got. Okay. So first we're solving this, and some people might say, Mr. Murray, E. Oh no, Mr. Murray, you're not supposed to use E. E is like a number, and that is true. We will learn eventually about a constant that's called E, but for right now we're pretending like it's a letter. And even with any constant like E, you couldn't combine the E squared and the E anyway. Not anything you got to worry about, but it is just a variable here. Okay, so here what I want to do is I want to factor this one. Okay, because I noticed that there is a b value here of negative 15. Okay, so that means that I can't use the square roots method. Okay, there's no way for me to factor this as a squares. Also, there's no GCF that I can remove because this number is 1, right? They don't have a common factor. These might, but this one, it's not in common with this factor here. So you usually want to see if you can do a GCF first, but the GCF is usually going to happen when A is not equal to 1. Okay, so I put my E squared, my 54. Now I need to multiply to 54 and add to negative 15. So I need a negative and a negative. So a negative times a negative is a positive, and then a negative plus a negative is a negative. So what I'm going to do is 9 times 6 is 54. Negative 9 times negative 6 is also 54, and negative 9 plus negative 6 equals negative 9 minus 6 equals negative 15. So I've got E squared minus 15E plus 54 equals 0, and also equals E minus 9, E minus 6. So if this is equal to 0, then forget about this. Let's just solve this. And what makes that true is when E equals 9, because then we get 0 times something, and then when E is equal to 6. So those are our two solutions here. Okay, so it's just a straightforward factoring. Set up the box, find the sides, rewrite into factored form, and then just make one of them equal to 0, solve, make the other equal to 0, solve. Okay, coming down here to our medium problem, so to speak. Okay, this one we could try to factor. One thing that you might notice is that the 4, the 28, and the 80 all have a common factor of 4. So because it's an equation, because there's an equal sign, and only because there's an equal sign, I'm going to divide everything by 4. Okay, because if I do the same thing to every single term in this equation, then what I'm doing is I'm keeping everything balanced, right? I'm doing the same thing to both sides. So this becomes m squared minus 7 equals 20. Okay, then you add 7. You get m squared equals 27. Okay, and I'll solve that in a minute. The other way to do it is just to add 28 off the bat. And then you get 4m squared equals 108. Right, you divide by 4. And you get m squared equals 27. Now this is setting up for the square roots method. The reason that I did not use another method, for example, factoring, 2 reasons. One, factoring, you need to have it equal to 0. I already see it's equal to 80. So to factor, I would have to be moving this 80 back to the other side. The other thing is you can really only use factoring in this kind of example when you have a difference of squares. So in other words, it's a minus, but these are both squares. And they're not, and I know that when I move the 80 over to get 108, that's not going to make it, if I move the 80 over, right, that's probably not likely to have made it a square either. So when I see something like this, I'm going to lean towards using the square root method, okay? So now, how do we solve m squared equals 27? Because that is the thing we need to solve. So remember, when you have it alone, you take the square root to cancel out the m squared. That cancels the squared. And then you do the square root of 27. Now 27 is equal to 9 times 3. So the square root of 27 equals the square root of 9 times the square root of 3. So the square root of 9 is 3. We leave the square root of 3 as is. And then don't forget, you're going to put your plus or minus right in front of it. Okay? Last here is we have this one. Now again, this one's going to require factoring. We have a b value. It doesn't look like we're going to be able to cancel that out. And remember what I said earlier on. A positive a keeps wrong answers away. So I've got 2 options. I could either multiply every single thing by -1, and that would keep both sides equal and make this go away. What I'm going to do is I'm going to add the 49h squared to both sides. I'm going to subtract the 42h, and this is only one way to do it. You don't have to do it this way if you don't want. So what happens is I'm basically moving everything over to the other side. Because then what happens is the 49, this becomes a positive, and right, you can always do the same thing on both sides. Okay, this becomes a negative, but that's okay because this is a positive a, and then I get plus 9 because the 15 minus the 6, and then it's equal to 0. Here's another way you could think about this one. If I move this all over. If I move everything out of there, right? So that is to say, if I add 49h, right? Yeah, 49h squared, gone. If I subtract 42h, gone. If I subtract 6, gone. So what's left on the left side? Nothing. 0, right? Literally, there's nothing there. So we put the number that literally means nothing. Okay? So now I need to factor this, but this is a little bit easier for a couple reasons. 1, it's equal to 0. 2, the a is positive. So now I box it. Okay, I put my 49h squared and my 9 here. Now, this is a strategies I've been thinking about, right? So we know that we need to figure out what goes on the top and the left, but maybe let's think about some patterns we see that might make it easier. One thing I notice is 49 doesn't have too many factors. It's 1 in 49, and it's 7 in 7. 9 is 1 in 9, 3 in 3. Okay? So what does that mean? Well, what that means is that we essentially have to have 2 perfect squares here, right? So either we have to try really big numbers, we have a situation there, or we also have 2 perfect squares. So when I see that a and c are both squares, what I'm going to try first is I'm going to try to see whether the whole thing is a square, right? If Because if it's a perfect square, this will be a square and this will be a square. I'm not saying it is, but I'm not saying this one is, but I'm saying when it is a square, that will happen. So let's see if we can get it. Now, the only other thing is, okay, the -4, this is a negative. So what that means is we're going to have to make this a negative, because what's going to happen is you're going to get -21h. If it's a negative, because it's a negative times a positive, right? And you need these two boxes to add up to the -42. So what we get is 0 equals 7h minus 3, 7h minus 3, or in other words, 7h minus 3 squared. Okay, if you use I recommend that you really consider using my website, factor.willnot.fail, for a little extra factoring practice if you're still stuck on factoring, because it does things on the factoring, like, for example, remember to write it as a square. Okay, and then what makes this equal to 0, that's h equals 3/7. Okay, and if it's something you're struggling to do, set this equal to 0 and get h alone. Okay, and because the factors are the same, you only get one unique solution, right? There are two factors, but it's the same thing. Okay, and what we're going to learn next year is that because this is a square, this is an even power on this thing, what's going to happen is at 3/7, it's going to bounce off the graph. Okay, versus if there was two different ones, each with a power of 1 here, it would go through the graph. All right, now on to the geometric sequences here. So we know that they're geometric. Okay, we know that because we can see they're not being added by the same thing. And if I don't give you a sequence that's geometric or arithmetic, I can't ask you to write the rule, because there's no rule that you can write there. Okay, so first of all, let's say I don't know how to go from term to term. I don't know how to get from 3 to 4.5. I'm not sure. What I'm going to do is I'm going to take 4.5 and I'm going to divide it by 3. And that's going to give me a number, right? Think about if this was my equation. Well, that's the same thing as to say 3r equals 4.5. In other words, it's going to give me the number that when I multiply it by 3 will get me 4.5. And that's what I'm looking for, right? That r that gets me from one term to the next. Okay, so that's just showing you why dividing a term by the one right before it gives you that ratio that you're looking for. So the ratio you should get is 1.5. Okay, so explicit rule. So the ratio is 1.5 and the first term is 3. So the explicit rule, remember, first we set up f of n equals the a value, which we don't know yet, times 1.5 to the n, because the 1.5 is the thing you're multiplying over and over, and to the n means multiplying over and over. Okay, now remember, with the explicit rule, we're plugging in 1 and we're getting 3. We're plugging in 2, 4.5, 3, 4, and so on. So what that means is that if I plug in 1, right, if n is equal to 1, then f of n needs to be equal to 3, because the first term is 3. And 1.5, okay, to the first is 1.5. That's the reason I choose the first, because anything to the power of the 1 keeps it the same. Okay, and then I divide by 1.5 to get it alone, to get a alone, and 3 divided by 1.5 is 2. So my final function is f of n equals 2 times 1.5 to the n. So again, the process is you first find your ratio. You plug your ratio in, because the function's always going to be like this. F of n equals a times b to the n. And then we talked about how, well, it's the b really stands for the common ratio. So you find your ratio, you plug it in, and then you choose an x and a y, or in this case an n and an fn. You choose a pair. You plug in the term number for n, so term 1, you plug in 1. You plug in the term value for your f of n or your y. You solve for a, and then you bring it all back together. Because now that a is 2, right, this will make sure that when you plug in 1, you get 3. Now, to check your work, if I plug in 2, what should I get? Right, I should get 4.5. So 4.5 equals 2 times 1.5 to the 2. When I plug in 2, I should get 4.5. So 1.5 to the 2, or 1.5 squared rather, I should say. So we get 4.5 equals 2. 1.5 squared is equal to 2.25, and 2 times 2.25 is 4.5. So we know it checks. Okay? So this is our this is our explicit rule. Okay, recursive. First, state the first term. Then, you know, every other term is equal to the one right before it times 1.5. Okay? So the first term is 3. Every other term is the term before it times 1.5. Okay? And remember, if hopefully you've caught on by now and you've seen the only thing that is changing is the 3, because it starts at 3, and 1.5 because that's the number I'm multiplying. All right, last one. So now it's a similar thing. Now here, maybe you see a pattern. So you see that I'm multiplying the top by 2, 2, 2, 2, 2. I'm multiplying the bottom by 3. 3 times 3, 3 times 3, 3 times 3. Now to make the signs alternate, positive, negative, I just make it a negative 2/3. And it doesn't matter whether you put the negative with the 2 or the 3, as long as one, or the other thing you could do is you could put the negative right before it like this. Okay, I actually like that a little bit better, but it doesn't really make a difference as long as just one of them is negative. Okay, and the first term, 2/3. Okay, so let's set up the explicit. So I have the rule f of n is equal to a, we don't know it yet, times negative 2/3 to the n. Okay, so now, again, we remember our term numbers. So the first term is 2/3. So when you plug in 1, you get 2/3. When you plug in 2, you need to get negative 4/9. 3 is 8/27, etc. So let's plug it in. So 2/3 is equal to a times, okay, negative 2/3. So when I plug in 1, I get 2/3. So basically 2/3 to the 1 is 2/3, or I guess negative 2/3. And then to get rid of this, I multiply by 3/2. And then what I do to the left, I need to do to the right. And it needs to be a negative 3/2 because you want to cancel the negative 2. Boom. 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 And a is equal to negative 1. And if you think about it, negative 1 times negative 2/3 equals positive 2/3. Okay? So f of n is equal to negative 1 times negative 2/3 to the n. That's our rule. Okay? Recursive, f of 1 equals 2/3. So the first term is 2/3. And every other term is the term right before it times negative 2/3. Okay, so if you found this video to be helpful, I know it's on like the longer side for a do now video, but I really thought I would pack in a lot of additional practice to make sure you guys are staying fresh with your skills. I'm looking forward to seeing everyone at tomorrow's hangout at 10 a.m. I'm excited for some really awesome math. So keep it up. Don't forget to love your math. And remember, you can do it. All right, thanks much for watching, folks. Have a wonderful day, and I'll see you next time.